Crash course on data science, data analysis, visualization, wrangling and cleaning. Introduction. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. It involves analyzing and interpreting complex data sets to identify patterns, trends, and relationships that can be used to make informed decisions. Data analysis and visualization are two of the most critical aspects of data science. In this article, we will provide a crash course on data analysis and visualization, including the tools and techniques used in this field. We will also share some exciting stories and examples to excite our readers. Data analysis. Data analysis involves processing, transforming, and modeling data to extract meaningful insights. It can be divided into 4 stages: data preparation, exploratory data analysis, statistical modeling, and deployment. Data preparation involves cleaning and transforming raw data to make it suitable for analysis. Exploratory data analysis, EDA, involves visualizing and summarizing data to identify patterns, trends, and outliers. Statistical modeling involves using mathematical models to make predictions and draw conclusions from data. Deployment involves implementing the results of data analysis to solve real-world problems. One of the most exciting stories in data analysis is the story of how Target figured out a teenage girl was pregnant before her father did. The story goes that Target was analyzing purchase data to identify which customers were pregnant, so they could send them targeted advertisements for baby products. One day, a man stormed into a Target store demanding to know why his daughter was receiving baby product coupons. As it turned out, his daughter was indeed pregnant, and Target had figured it out based on her purchase history. This story is a testament to the power of data analysis and how it can be used to uncover hidden insights. Data visualization. Data visualization involves creating graphical representations of data to facilitate understanding and communication. It can be used to convey complex information in a simple and intuitive way. Data visualization can be divided into 2 categories: exploratory and explanatory. Exploratory data visualization is used to understand the data and identify patterns, while explanatory data visualization is used to communicate insights to others. One of the most exciting examples of data visualization is Hans Rosling's TED Talk on "The Best Stats You've Ever Seen." In this talk, Rosling uses animated visualizations to explain how the world has changed over the past 200 years in terms of wealth, health, and population. His visualizations are both beautiful and informative, and they help to convey complex information in a way that is easy to understand. Data wrangling and cleaning. Data wrangling and cleaning are critical aspects of data science that involve transforming and preparing raw data into a format that can be analyzed. This process involves several steps. 1. Data collection. The first step in data wrangling is collecting data from different sources such as databases, APIs, or spreadsheets. 2. Data integration. After data is collected, it is important to integrate it from different sources into a single data repository. This is done by matching data based on a unique identifier. 3. Data cleaning. In this step, data is cleaned to remove duplicates, inconsistencies, and errors. The goal is to have accurate and consistent data that can be analyzed. This step may involve handling missing data by either removing or imputing values. 4. Data transformation. Data transformation involves converting data from one format to another. For example, converting a categorical variable into a numerical one, or changing the format of a date field. 5. Data reduction. In some cases, the dataset may be too large to analyze. Data reduction involves reducing the size of the dataset by selecting only the relevant variables or observations. 6. Data normalization. Data normalization involves scaling the data to a specific range or distribution to make it easier to analyze. 7. Data sampling. Data sampling involves selecting a subset of the data to analyze. This can be done randomly or through stratified sampling. 8. Data formatting. In this step, the data is formatted to match the requirements of the analysis tool or model being used. There are several tools and techniques that can be used for data wrangling and cleaning. Some popular tools include Excel, OpenRefine, Python, and R. In 2016, the City of Boston released a dataset containing over 300,000 parking ticket records. However, the data was extremely messy, with incorrect dates, misspelled names, and inconsistent formatting. A team of data scientists from Northeastern University used data wrangling techniques to clean and transform the data into a format that could be analyzed. They found that the city was issuing more tickets in low-income neighborhoods, leading to calls for reform in parking enforcement policies. In another example, a team of data scientists from Airbnb used data wrangling techniques to clean and transform their user data. They found that the number of Airbnb listings in a city was strongly correlated with the number of Instagram posts from that city, indicating that social media was driving the growth of Airbnb. In brief, data wrangling and cleaning are essential steps in data science that involve transforming raw data into a format suitable for analysis. This process involves several steps, including data cleaning, transformation, reduction, normalization, and formatting, and can be done using a variety of tools and techniques. Here are top 12 data science trends. Data science is a rapidly evolving field, and there are many emerging trends to watch out for. Here are the top 12 data science trends to look out for in the coming years. 1. AI and machine learning. AI and machine learning are becoming increasingly important in data science, as they enable computers to learn from data and make predictions. 2. Big data. The amount of data being generated is growing exponentially, and data scientists need to be able to handle and analyze this data efficiently. 3. Internet of Things, IoT. IoT devices are generating vast amounts of data, and data scientists need to be able to analyze this data to extract insights. 4. Cloud computing. Cloud computing makes it easier to store and analyze large amounts of data, and it is becoming increasingly important in data science. 5. Natural language processing, NLP. NLP is becoming increasingly important in data science, as it enables computers to understand and interpret human language. 6. Blockchain. Blockchain technology is becoming increasingly important in data science, as it enables secure and transparent data sharing. 7. Data privacy and security. As more data is being collected, data privacy and security are becoming increasingly important in data science. 8. Edge computing. Edge computing involves processing data closer to the source, which can help to reduce latency and improve. 9. Data ops. Data ops is a new approach to data management that emphasizes collaboration and automation, and it is becoming increasingly popular in data science. 10. Explainable AI. Explainable AI is becoming increasingly important in data science, as it enables users to understand how AI models are making decisions. 11. Augmented analytics. Augmented analytics involves using machine learning and AI to automate the data analysis process, making it easier for non-experts to understand and use. 12. Data governance. Data governance involves managing and ensuring the quality, availability, integrity, and security of data, and it is becoming increasingly important in data science. Summarization. Data analysis and visualization are two of the most critical aspects of data science. Data analysis involves processing, transforming, and modeling data to extract meaningful insights, while data visualization involves creating graphical representations of data to facilitate understanding and communication. There are many tools and techniques used in data analysis and visualization, including statistical inference and data visualization software. There are also many emerging trends in data science, including AI and machine learning, big data, IoT, cloud computing, NLP, blockchain, data privacy and security, edge computing, data ops, explainable AI, augmented analytics, and data governance. Here is a poem on data science. In the world of data science, we explore a world of numbers, patterns, and more. Data analysis and visualization helps us to see with crystal clear precision, from cleaning to modeling and deploying. Our data needs constant preparing. Exploratory analysis to see the patterns and trends that need to be in a world of big data and IoT. cloud computing and NLP. We must adapt and learn anew. To keep up with the ever-changing view, AI and machine learning lead the way. Augmented analytics help us play. Data governance and privacy, we must obey. To ensure our data is safe each day. In the world of data science, we see a future full of possibility. With trends emerging, we must prepare to stay ahead and be aware. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html $aid = 7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our Anhub Metaverse channel, and please watch more interesting videos here.